Welcome back. Let us continue with integers. Today we will cover properties of multiplication and properties of division. Properties of multiplication. Under properties of multiplication. Closure property. Example. Consider integers 2 and -2. We perform multiplication operation. 2 into -2 equals -4. In general, if a and b are two integers, then a into b will be an integer. Now, a into b equals ab. A into -b equals -ab equals -a into b. -a into -b equals ab. Commutative property. Example. Consider integers -3 and -7. -3 into -7 equals 21. -7 into -3 equals 21. We observe, the result is same even if we change the order. Hence, multiplication is commutative for integers. In general, if a and b are two integers, then a into b equals b into a. Associative property. Example. Consider integers 2, 3 and 4. We perform multiplication operation, 2 into 3 into 4. Case 1, let us group 2 and 3 together, we get. Case 2, let us group 3 and 4 together, we get. We observe, the result of case 1 and 2 are same. So, regardless of how the integers are grouped, the result is same. Hence, multiplication of integers is associative. In general, if a, b, and c are integers, then multiplicative identity. Example. Consider an integer, -3. -3 into 1 equals -3. 1 into -3 equals -3. The product, meaning multiplication, of any integer with 1 gives the same integer. In general, if a is an integer, a into 1 equals 1 into a. Multiplicative inverse. The product of any integer and its reciprocal gives the result as 1. Example. 3 into 1 by 3 equals 1. 1 by 3 into 3 equals 1. In general, if a is an integer, a into 1 by a equals 1. Property of 0. Example. -3 into 0 equals 0. 0 into -3 equals 0. So, the product of an integer and 0 is 0. In general, if a is an integer, then a into 0 equals 0. Distributive property. Example. Distributivity of multiplication over addition. 2 into 4 plus 5 equals 2 into 4 plus 2 into 5. 18 equals 18. Example. Distributivity of multiplication over subtraction. 9 into -5 minus 8 equals 9 into -5 minus 9 into 8. -117 equals -117. So in general, for any integers a, b, and c, a into b plus or minus c equals ab plus or minus c. Hence, integers possess the distributive property of multiplication. Now, properties of division. Under properties of division. Closure property. Closure property does not hold good for division of integers. For example, for divided by 2 equals 2, here, 2 is an integer. But 7 divided by 3 equals 7 by 3, and 7 by 3 is not an integer. Commutative property. Integers division does not follow commutative property. Example. Consider integers 6 and 3. 6 divided by 3 equals 2. 3 divided by 6 equals 1 by 2. So, 6 by 3 is not equal to 3 by 6. We know, for pairs of integers, when arithmetic operation is executed, should give the same result when the order is changed. This statement must be satisfied to say division is commutative for integers. But for division, for two integers a and b, a divided by b is not equal to b divided by a. Associative property. Associative property does not hold good for the division of integers. if a, b and c are three integers, then. Example. Consider integers 4, 2 and -2. -1 is not equal to -4. Property of 1. Any integer divided by 1 gives the same integer as the quotient. In general, if a is an integer, a divided by 1 equals a. Property of 0. When 0 is divided by an integer, the result is always 0. In general, if a is an integer, 0 divided by a equals 0. This ends our topic on integers. Thanks for watching. Check out our other videos and subscribe to our YouTube channel. Until then, stay safe and live healthy.